Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I'm going to talk about flotation. When you put an object in a liquid, it either can float or it can sink. This is the principle which decides whether the object will float or it will sink. Let's take this scenario. There is a container full of water, okay? And in that container you put a solid object. Natural thinking is that some water will come out from this container. How much water will come out from this container? The volume of this solid object, that much of the water will come out from this container. Then only this object can be in this liquid or water. Okay. Now Archimedes identified that how much of water has been displaced by this solid object, that water will create that much volume of the water and equivalent weight of the water, that will create the upthrust on this object. Okay. So whenever you put any solid object in liquid, here the case of water, this object will experience an upward force equivalent to the water which has been displaced, or the liquid which has been displaced. Okay. That upthrust is also called force of buoyancy, denoted by Fb. And the weight of that solid object is denoted by W here in this example. Now, as I mentioned, that upthrust is equal to the weight of the displaced water. So we all are aware of that weight is equal to the mass of the object multiplied by the acceleration due to gravity. Here we are considering the object as displaced water, right? So the mass of the displaced water can be found as volume of the displaced liquid multiplied by the density of the liquid. Okay, that will give us the mass of the displaced liquid. And if we multiply that with acceleration due to gravity, that will give the weight of the displaced liquid. And this itself is putting the upthrust. So therefore, we can write this as a force of buoyancy, Fp. That is what has been written here, that upthrust Fb is equal to volume of the displaced liquid multiplied by the density of the liquid multiplied by the acceleration due to gravity. Now, we know, as I discussed, that volume of the displaced liquid will be equal to the volume of the solid which is immersed into the liquid. So this is the link. Volume of the displaced liquid will be equal to the volume of the solid which is immersed in the liquid. The object can be fully immersed, the object can be partly immersed. Whatever part of the volume which is immersed in the liquid, that much of liquid will be displaced out. And therefore, volume of the displaced liquid must be equal to the volume of the solid immersed, multiplied with the rho of the liquid multiplied by the acceleration due to gravity. And that's how you find the upthrust. Be clear that this is volume of the solid immersed, which is replacing exactly the same volume of the liquid. Okay? And this is the link between the solid volume and the volume of the displaced liquid. Now, the principle of flotation, where an object floats and in what scenario the object will sink, that is decided by this principle, which we also called Archimedes principle. The weight of the body, whenever you even if this body you take in the air, earth will pull it down, so there will be weight working on that, right? That is how we say that this is, say, for example, 10 Newton weight of the object, because earth pulls it down, so that's the weight. Okay, so weight of the body must be equal to upthrust, or in other words, the weight of the body is balanced by upthrust, and in that scenario the object will float. Okay, now let's look at these three situations. If the upthrust is greater than the weight of the body, so if upthrust is greater, suppose upthrust is 10 Newton in upward direction and weight is, say, 5 Newton, okay, then what do you expect? The resultant force of 10 minus 5 Newton, that is 5 Newton, will be working in the upward direction. And therefore, even if you bring this object in the body of the water and leave it, it will just spring back and come to the surface. Okay? Now there is another scenario where the upthrust is just equal to the weight of the body. Like upthrust is, say, weight of the body is 5 Newton and upthrust is also 5 Newton. Then what happens? The net force acting on the body is 5 minus 5, which is 0 Newton. So no net force is acting on the body, right? Therefore, this object in this scenario will just float in the body of the water. Here I have shown that it is the upper part of the solid is just matching with water, but this is not necessary. This object can float anywhere in the body of the water, right? And this is a situation where the upthrust will be exactly equal to the weight of the body. There is a third situation also where the upthrust is lesser than the weight of the body. Now, if weight is 5 Newton and upthrust is only 2 Newton, then what do you think? The weight is acting downward and it is having more force, that is 5 Newton, right? So, the net force acting on the body will be working in the downward direction, and that will be W minus FB, which will be equal to 5 minus 2, which is 3 Newton. And this 3 Newton is working in the downward direction, so this body sinks. Okay? So these are the three conditions in which the first two are the conditions of flotation, and the third condition is in which the body sinks. Be clear here, as I said, that you bring the object inside and then leave it, it will just spring back like a cork. If you just forcibly put that cork into the liquid, then it will come onto the surface. But once it is on the surface, then the upthrust will be exactly equal to the weight of the body. So both these are the example of flotation where weight of the body is equal to the upthrust. There is another way of looking at it, and let's consider that. So we know that principle of flotation is weight is equal to the upthrust on the body. Okay? Weight of the body, the way we had discussed that how the weight of the displaced fluid should be calculated. Likewise, we can calculate the weight of the body in air. If it is a solid object, so let's consider that as a volume of the solid is Vs and the density of the solid is rho s. Then this will give you the mass of the solid object. Okay? If you multiply that by acceleration due to gravity, that will give you the weight of the body. Okay? And we know that how upthrust is calculated, we have just found it out. So that will be the volume of the solid immersed. I have in short written SI, solid immersed, multiplied by the density of the liquid, rho L, multiplied with the acceleration due to gravity. Now this G and G cancels. And then you can write Vsi divided by Vs is equal to rho s upon rho of liquid. Now this entire flotation you can explain in terms of the density of the solid and density of the liquid also. Let's consider this scenario that the density of the solid is less than the density of the liquid. So if that is the situation, then what happens? Let's take some numerical example. Suppose rho of the solid is equal to maybe 5 gram per centimeter cube. Let's take that example. And rho of the liquid is equal to, say, let's consider water itself. Okay, suppose 1 gram per centimeter cube. Okay. Now, in this case, rho of the solid is more than the rho of the liquid. We are considering the case of rho of the solid less than rho of liquid. Suppose this be a kind of not 5, rather 0.5. Okay. Then the rho of the solid is less than the rho of the liquid. Okay. So from this relationship, then what we get? V of the solid immersed divided by volume of the solid will be equal to 0.5 divided by 1, which is equal to 0.5, which also says that volume of the solid immersed will be equal to 0.5 of the volume of the solid, right? What it indicates that the solid immersed will be only 50% of the total volume of the solid. Okay? So if the density of the solid is less than the density of the liquid, then the body will be only partially immersed. Let's take another scenario that the density of the liquid is exactly equal to the density of the solid. For example, this scenario. So, rho s is also 1 gram per centimeter cube and rho L is also 1 gram centimeter cube per centimeter cube, which is the density of water. So what happens in this scenario? Volume of solid immersed divided by volume of solid will be equal to 1 upon 1, which is equal to 1, and which leads to volume of solid immersed will be exactly equal to the volume of the solid. It means that entire object will be inside the water. Okay. So this is that scenario where the density of the liquid is equal to the density of the solid. But there is this scenario also where the density of the solid is greater. Say density of the solid is 2 gram per centimeter cube and density of the liquid is only 1 gram per centimeter cube, which is again water. So what happens in this scenario? Volume of solid immersed divided by volume of solid will be equal to rho S by rho L, which is equal to 2 divided by 1, and therefore this becomes 2. What it indicates that volume of solid immersed is more than the volume of the solid. What is that situation? That situation is that the body has come down completely. So it has sunk. Okay. So these are 3 ways in which you can understand the principle of flotation considering all these 3 scenarios, both in terms of the upthrust and weight and also in terms of the density of the solid and density of the liquid in which that solid has been put. Let's draw a parallel to it, right? You go to your class, there are 3 kinds of students in every class, okay? There will be some students who are very intelligent and studious kind of students, and whatever subject is taught, they will understand it, grasp it, and they will answer the questions. So those students sit in the front row. Consider this as a classroom and consider this as a kind of set of those students who are very intelligent, so they sit in the front row. Always they will make eye contact with the teacher, and whatever questions the teacher asks, they will respond. But then there is another set of students who overall understands whatever is being taught. But there are situations where they remain confused. So those people will prefer sitting in the middle of the class somewhere. If the teacher asks some questions and making the eye contact with the student, then that student responds to the extent the student knows. Otherwise, he says that, okay, fine, sir, I don't know about it. Right? But that student is okay. So that kind of student will prefer sitting in the middle row somewhere. Okay. But there is this third variety of student whose brain has not been used in terms of Three Idiots movie. That kind of students, when they enter into the class, they will straight go into the back bench and they will take position at the back bench. They will always prefer avoiding the eye contact with the teacher so that any question should not come to them. These people will the back bench, right? So you can understand these 3 situations with this example also, okay? I hope that you have understood what is the principle of flotation, how it is used, how it can be interpreted in 2 different modes. One in terms of the upthrust and weight, another in terms of the density of the solid and density of the liquid. Thank you.